Hello, I am Jyotika. Welcome to my channel. You can visit my website alevels.excellingpsychology.com. I'll link it in the description box below. On that website, you will find the document that I have used in this video, as well as other material that will be helpful to you in preparing for your AS and A-level psychology exam. In today's class, I'm going to be explaining the introductory part to the Dement and Kleitman course study of the syllabus, which is the first study for the new curriculum. For every study, you have to prepare an introduction section, a method section, a results section, and an evaluation section. Within the introduction section, you have to prepare the psychology being investigated, the background, and the aims of the study. If you're not sure how you're supposed to be preparing your studies, do refer to the syllabus guidelines. It is all very clearly outlined there, and those are the guidelines that I'm following for my videos. So today for Dement and Kleitman, we'll prepare all the sections under introduction. That is, I'll explain all those sections to you. Then I will also show you what type of questions come in the paper from the introduction section, along with model answers to show to you how you should be answering them. I know your curriculum is new, but you can very freely use past papers of the older curriculum to prepare for your exams. The older curriculum was not much different from yours. A few course studies were different. Wording of the questions, marks allotted was slightly different, but the nature of the questions are the same as the ones that are going to be seen in your paper. So especially for the course studies that are overlapping with the previous curriculum, there are 8 such studies. You can definitely make use of the past papers and for your research methods paper too. Okay, so I will be showing you those past papers only which are from the older curriculum. Don't think they are irrelevant to your course, they are very much relevant to yours. Okay, so let's begin today's class. Dement and Kleitman sleep and dream study. First, let us understand when we are preparing psychology being investigated section, exactly what are we preparing. When we are preparing this section, we are understanding and preparing to write about the mental and behavioral concepts that were looked into in a study. What is psychology? Psychology is the science of mental behavior, mental processes and behavior. So if I'm telling you, you need to prepare psychology being investigated, I mean you need to prepare about the mental processes and behavior that were investigated in the study. Now, broadly speaking, Dement and Kleitman were looking at the relationship between dreaming and stages of sleep. That is something we understand from the title also, because in the brackets we see sleep and dreams. So to be more specific, they were looking at the association between dreaming and stages of sleep. They wanted to know in which stage of sleep does dreaming occur, and a few more details that we will see ahead. So first, let us understand what dreaming is. Now, all of us will feel there's nothing to define in dreaming because we all have experience of dreaming. So we all know what it is. But knowing something and putting it into words is different. So let us understand in proper words what dreaming is. Dreaming is any sensations, images you experience when you're sleeping and they occur to you spontaneously, that is involuntarily. So when you're sleeping, often you see things, you hear things. So you might see being on a picnic, you might hear your friends talking to you, you might even experience some emotions. So you feel sad or anger, sorrow or anger or happiness in response to what you're seeing. So all these sensations, emotions, images that are coming to you when you are sleeping are known as dreams. They are definitely involuntarily because you don't deliberately decide as you're sleeping that now I want to see a dream and this is what I want to see in my dream. So they're different from thinking, which takes place when we are awake. So dreaming is simply all those things that we see and hear when we are sleeping, which occur to us spontaneously on the spot without any deliberate planning that we have done. Now the researchers wanted to see, as we've seen earlier, in which stage of sleep dreaming occurs. So first let us know which are the stages of sleep. What is found is that human sleep can be divided into 2 broad stages according to 2 aspects of sleep waves. One is frequency and one is amplitude. Okay, this becomes a little technical here, but there's nothing difficult about it. It's very easy to understand. You know that our brain is made up of neurons. Brain cells are known as neurons. Now, sometimes our neurons are working very rapidly. That is, neurons are speedily working, as in supposing you're thinking about something very quickly. So, a lot of thoughts are being generated by you. You will experience this sometimes. You also feel fatigued sometimes after thinking a lot, because your neurons have to do a lot of activity when you're thinking. Supposing you're sitting and thinking some worrying thoughts like, tomorrow my paper is there, I'm not ready for it, what will happen? So a lot of neurons have to work that time when you are thinking a lot. So in the same way, when you are dreaming, as you're sleeping, you're dreaming, we saw that a lot of sensations, images are coming to your mind. So when they're coming, it is obvious that your neurons in the brain must be working a lot. When your neurons are working very speedily, or when we roughly say that they are working a lot, we say that there is frequent activity of the neurons. So frequency, as we know, is something occurring fast or rapidly. Now, if your neurons are working rapidly, and we use a technique which is called electroencephalography, EEG, to look into the activity of your neurons, what we'll find on the output of that EEG is that some waves will be generated to show how the activity is taking place in the neurons. And these waves will be occurring very fast. So we'll find these waves very close together, indicating that there is a lot of frequency in the activity of neurons. To make this more clear to you, I'll just show you an image. Okay, you have good images of EEG technique in your course companions as well. So what you can see in the EEG technique is, we will see this more closely, but right now I want you to understand very basically what's happening here. There's a person whose brain has been connected to a machine with the help of some wires. Okay, now that machine has a screen on which it displays its output. So as this person's brain is working, that is, as his neurons are working, some output is being generated on the screen of the machine. Wherever we see fast output, like in this case you can see, we just have to keep in mind this person is awake, he's not sleeping. Now in this case, as you can see, the waves on the machine are close together, so they seem to be occurring fast, right? So these are known as frequent waves. Frequent waves on the screen of the EEG indicate that a person's neurons in his brain are working fast, they are working rapidly. That is why we see frequent waves. Otherwise, if the neurons were working slowly, we would see slow waves. So the waves would have spaces between them or gaps between them. Okay, so one thing that we consider to understand which stage of sleep a person is the frequency of sleep waves, like we saw on the screen right now. And as I explained to you, this frequency of sleep waves is indicating how quickly his neurons are working inside his brain. So there is one stage of sleep in which the neurons are working rapidly, very quickly, so we get to see a lot of frequency on that monitor. And there is another stage of sleep in which the neurons are not working as rapidly. So we don't get to see such fast waves on the monitor. We'll see more of that ahead. Right now we just understand the idea. The next feature of sleep waves is amplitude, based on which we characterize sleep stages. Amplitude is the peakedness or the height of sleep waves. Okay, again let's look at it in the diagram. So this is EEG recording as we saw earlier. Sometimes you can see in some of the waves, there is a high peak. So you see the wave is going up a lot. So these are said to be high amplitude waves. Sometimes you see that there's not much of a peak in the waves. Their height is less. So these are known as low amplitude waves. Now what does amplitude indicate about neuronal activity? When there is low amplitude in neuronal activity, that means our neurons are not very much in sync. Our brain neurons are not working collaboratively, or they are not consolidating or synchronizing information. They all are doing their independent functions. Then we see that there is low amplitude in brain waves. However, when there is high amplitude, when we see those peaks in the brain waves, That means that the brain neurons are working in synchrony. They are all working together and consolidating some of the information that they have received. So there is one stage of sleep such in which there is a high amplitude of waves. That means that the neurons are working in sync with each other. And there is another stage of sleep in which the neurons are not working so much in sync with each other. So they're not consolidating information. So based on this frequency of waves and the amplitude of waves, we can characterize sleep stages into two based on their combination. Okay, now I know in many of your minds, those students who are very exam oriented, you must be thinking, do you need to explain all of this in the paper? No, what you're seeing on the screen is what you need to explain on the paper. Why I've explained all of this is because I know some students like to fully, deeply understand what they are learning and not just know how much they need to prepare for the exam. So I'm giving you a conceptual understanding, the idea behind the study. It's good practice to learn what is actually being investigated in a study properly. Not only if you have an interest in it, but also it motivates you to learn what is ahead better, even for your exam. Because very often we find students who become demotivated because they're not really seeing what the meaning is of a study, so they cannot connect with it and they feel that it's just there for the sake of making the syllabus difficult or the exams difficult. So that those ideas don't come in your mind and you see how important psychological research is and what value it has, it is good to take interest in understanding concepts fully. It takes a few minutes of your time, but it really helps you to build interest in the subject. Okay, so we have two stages of sleep based on frequency and amplitude of sleep waves. So now let us understand which are those two stages of sleep. The first is called NREM sleep. NREM is an acronym for non-rapid eye movement sleep. So the name itself describes what type of a stage of sleep it is. It's non-rapid eye movement. Our eyes, when we are sleeping, they tend to move under the lids. Sometimes we see that there are slight movements in the eyes or slow movements, not quick or rapid movements. So that stage of sleep in which if you actually look at a person, you will see that his eyes are moving very gradually. In between, intermittently, you can see a few movements in the eyes. That stage is known as NREM stage of sleep. Our eyes move slowly and that is an indicator that the brain neurons are also working slowly, which means that we won't see much of a frequency of waves on the EEG monitor as we were discussing ahead. So in this stage of sleep, my neurons are not working rapidly. There's not much frequency in the activity. So even if I look at the EEG monitor, which is studying somebody's sleep waves, I will see that the waves are occurring very slowly. So I will get to see waves that are slow in nature. This is a stage of deep sleep. As you can readily imagine, it's easy to understand. If your neurons are working slowly, how will you feel? Less tired, because your brain is not working too much. As I gave you an example before, when you think a lot, you feel tired because your neurons have had to work a lot to help you to think so much. If your neurons are working slowly, that indicates that your brain is not working too much, so you feel rested. So this is a deep stage of sleep. Dreaming is not found to occur at this stage. This also follows logically. We just saw that dreaming means seeing things, hearing things, feeling things when we are sleeping. So if that is to happen, as I'm sleeping, I'm to see, think and feel so much, my neurons will be very active. So that will be seen in the activity of neurons that the activity is fast or frequent. If I'm not seeing that, then I must not be dreaming at that time. So it follows logically that in the NREM stage of sleep, when we are resting, when the neurons are not working much, we are not dreaming in this stage of sleep. In terms of the amplitude of sleep waves, we find that in this stage of sleep, the waves have high amplitude. So there are a lot of peaks that we get to see in the waves. Okay, so you will see high peaked waves that are occurring slowly in this stage of sleep. Okay, my diagrams, my drawings are just there to help you visualize a point in your mind. Please don't take them seriously. Please look at proper diagrams in the textbook. whichever textbook you're referring to, definitely there'll be an EEG diagram and that. So please look at those to understand properly NREM, REM stages of sleep. Okay, so this stage of sleep, NREM stage, has high amplitude. As I had told you earlier, when there is high amplitude, that means your brain is consolidating or synchronizing information. In the day, you use a lot of your mental processes. So you attend to many things, you perceive many things, you develop a lot of memories. They all need to be consolidated or made long lasting in your brain. So when you're in deep sleep, that time the few neurons which are working, they are consolidating or synchronizing all this information that you have picked up in the day. That is why you will hear advice like have a deep sleep or have a sound sleep before your exam. After you have studied something, don't study something just before the exam and run to write your paper. Now why is that? Because when you go into deep sleep, the neurons which are working, they coordinate and they share all the information that you have picked up in the day, and they form proper memories, they form proper information connections out of whatever you have learned in the day. Okay, so they make your information, your memory stronger, and that helps you to write a better paper. It is as if when you feed something into a computer also, if you fed in a lot of files, then it is good if before shutting down the computer, you give the computer a few moments just to sync everything together, just to link up all the information, so that when you restart it, that time all the information is in place. Everything has been coordinated by the computer. If you have just put in a lot of files and you haven't given the computer enough time to sync in all the files with each other, then what you'll find is that later on you have to search for one file from different places. All the information has not been put into one piece. So your mind or your brain also works in that way. Now this stage of sleep, like we are seeing, one, there is low frequency, the waves occur slowly, and secondly, there is high amplitude. So there's good coordination of the neurons that are working, but that does not mean that it is continuously or consistently this way. When we have NREM stage of sleep and we are seeing the output on the EEG monitor, no doubt we'll be seeing these slow waves occurring. But then in between, sometimes we will see some very frequent waves occurring, and then the waves will slow down again. So this sudden spurt or this sudden attack of a lot of activity of the neurons is what is called sleep spindles. Okay, so NREM stage of sleep, no doubt it's a deep stage and it's very rested sleep, but in between you get to see sudden bursts of activities of the neurons, and the purpose is the same because information is being synchronized. So sometimes information is needed from some neurons which are as such inactive, but that information is needed so that they become active for a while and then they get rested again. So in between we see spindles. Spindles are just short-lived episodes of rapid brain activity. If they were to prolong, then the stage of sleep would not be NREM, it would be the next stage of sleep. So spindles are just small bursts of activity, and that is how they are meant to be. So we just have to know that this is something, the sleep spindle is something that does occur in NREM stage. They occur intermittently. They are not very common or they are not very frequent. They occur once in a way during NREM stage of sleep. And NREM stage of sleep is further divided into 4 substages. Now this is not relevant to our discussion. This is something that we just need to make note of right now. We are not going too much into the depth of the stages of sleep because our concern is what is the relation of dreaming and stages of sleep. We are not purely interested in the stages of sleep. So we are not going to see into this more. We can just know that okay, NREM stage of sleep also has some subdivisions. So they must be characterized by slight changes in the frequencies and amplitudes. We can imagine that and just stop at knowing that. Okay, the other stage of sleep is known as REM, rapid eye movement sleep. It is the converse of the NREM stage. Again, the name itself describes what kind of a sleep stage it is. In the NREM stage of sleep, we saw that we get to see less frequent waves. That is, neurons are working slowly in the brain. In the REM stage of sleep, neurons are working rapidly in the brain. So the frequency of waves on the EEG monitor is going to be high. This is a stage of shallow sleep, and we don't really feel rested in this stage, and as we would expect, dreaming occurs during this stage. So the fast activity of the neurons is indicative of the fact that neurons are generating a lot of sensations, images in our mind, and that is why these sleep waves are occurring very fast. So this is definitely the stage in which dreaming occurs. This is also known as low amplitude sleep. If we are to see REM stage of sleep, the output for it on the EEG monitor, we'll get to see flat waves. They are rapid, they are frequent, they are close to each other, but they don't have much peaks. They appear more or less flat. And I've explained to you already about amplitude. That means that in this stage of sleep, information is not really being consolidated. All neurons are doing their independent jobs. They are generating different type of sensations and images in our mind. So they are not really syncing with each other at this point, which is why we call it low amplitude stage of sleep. Okay, so to just summarize what we have seen in the two stages of sleep, we have seen that there are two stages very distinctive from each other, NREM and REM. REM is that stage which is of our primary concern right now, because dreaming occurs in the REM stage, which has slow brain activity and not synchronized, or we can say low amplitude brain activity. So this is when dreaming occurs. It's the main focus of our study. But when we are saying that, okay, this is the stage in which dreaming occurs, then we should also know which is the other stage in which dreaming does not occur. Though we don't focus much on that, but we should just know what is the distinction. So NREM stage of sleep is that stage of sleep when dreaming does not occur. It is a stage of deep sleep characterized by slow brain activity, less frequent neuronal activity, and more amplitude of sleep, more consolidation and synchronizing. Okay, now if we go to see, this is the psychology that Dement and Kleitman were investigating. They wanted to establish strongly that dreaming occurs in REM stage of sleep. As such, in previous studies, there were indications that dreaming occurs in REM stage. That had been found previously. But there was no definitive evidence of this, the reasons for which we will see in the very next section, the background of the study. So primarily, Dement and Kleitman were seeing whether dreaming really occurs in the REM stage of sleep or not, whether concretely that can be taken as a fact or not. Now, to do this type of a study, they had to use what is called technology, brain scanning technology. Because if we want to know what neuronal activity or brain activity is taking place, then we have to use technology to be able to measure that. The technology which helps us to measure sleep waves and thereby the underlying brain activity that is taking place is known as EEG technology. EEG stands for electroencephalography. From a paper point of view, we have to know the terms well. So EEG stands for electroencephalography technique, and the machine which we just saw in the diagram previously, which helps us to perform this technique, is known as EEG machine or electroencephalogram. Electro means electricity, encephalo means in the brain, and graphy means imaging or investigating the brain. So that is from where the word is coming. Practice the spelling properly for your paper. Students make a lot of mistake in the spellings. Okay. Now EEG technique, how it works is we have to know something more about it, because it becomes a part of the psychology investigated in the study. It's an indispensable part of how Dement and Kleitman were able to study the relationship between sleep and dreams. So we have to know more about it. The EEG technique is such that it requires some electrodes to be attached to a person's scalp, as we had seen in the diagram. Let's just revisit that diagram once to make these points more clear. Okay, so while using the EEG technology, what is done is some electrodes are attached to a person's scalp. Now, if you look at these electrodes closely, what you will see is that there are some circular discs at the bottom of these electrodes. These are metal discs. And you will see that there are wires attached to the discs. Okay, so one electrode looks something like this. There is a metal disc at one end, and there is a wire that is connected to it. As we were just discussing about neurons, brain cells. So to get the activity of brain cells, we need to attach these electrodes to the scalp. What does it mean? Brain cells or neurons work on electric principle. That is, they keep generating some electricity when they are active. The more that neurons are active, the more that electricity will be generated. Because you can readily imagine, if more cells are active, more electricity is being generated. If less cells are active, less electricity is being generated. Now, metal is good conductor of electricity. So what these metal discs do is, they pick up electric activity from the underlying part of wherever they have been attached. Like you can see, there are so many electrodes on the person's scalp. Each electrode is picking up electric activity from the neurons which are just under that electrode. So from the surface of the brain, of course the electrodes are not going deep into the brain. So on the surface of our brain, whatever neurons are there and they are generating electricity, each electrode is picking up how much electricity is being generated. Of course, more electricity being generated, more activity. It's indicative of more activity in the brain. So that is how the electrode can tell us how much activity is taking place, by finding out how much electric activity is happening underneath. So that is the information that it picks up, the metal disc picks up, and then by means of a wire, it sends this information to the EEG machine. The EEG machine has a computer display or a screen for output. So the EEG machine picks up how much activity is there according to the electrode through the wires, and then accordingly it displays output on the screen. That is, if it finds there's a lot of activity, it starts showing fast waves on the screen. If it finds that there is less activity, it shows slow waves on the screen. In the same way, from the total output of all the electrodes, it finds out whether there is good amplitude in the activity of the neurons or there is less amplitude. So the synchrony is also determined in the same way. And with the wires, once the synchrony or the amplitude reaches the computer screen, then if the machine finds that there is good amplitude, it will generate high waves. Peaked waves will start coming on the screen. But if it finds that there is low amplitude, then flatter type of waves will come on the screen. So this is how the EEG machinery works. So coming back to our point, we were seeing that electrodes need to be attached to a person's scalp. We just saw why. These electrodes detect activity of neurons on the surface, as we discussed. They send that information to the machine. Once the machine comes to know that these are the waves, frequency, and these are the amplitudes, it can tell us whether the person is in NREM stage of sleep or REM stage of sleep. Now the researchers made use of one more technology, because as we will see ahead, they had more aims for their study. They wanted to find out something more, as we have been seeing from the beginning. Not only when dreaming occurs in which stage of sleep, but something little more. So for that, they also needed to record the person's eye activity. Eye activity means in what direction the person's eyes are moving, horizontally, left, right, or vertically, up, down, or mixed of both, or whether the eyes are still. They needed to know this also, that as a person is sleeping, in what direction and in what speed his eyes are moving, fast or slow. For that, they also made use of another technology which is called electrooculography. Electro means electric, oculo means eye, and graphy means imaging or study of eye movements, we can say. So electrooculography, as such, it does not have a separate machine. The EEG machine only conducts EOG for us as well. But if we are to speak very technically, we could say that the technique is called electrooculography, and the machine which records this is called electrooculogram. Physically, that machine is the same as the EEG machine. So EEG machine is the same, but the type of recording being done is different. EEG recording is to do with brain neurons, and EOG recording is to do with eye neurons. Just like our brain has neurons, our eyes also have neurons around them. You must be remembering from your studies of central nervous system in biology. Okay, I won't go into the depth of that, but eyes have neurons around them. So in the same way that we attach electrodes to a person's scalp, we can also attach electrodes near his eyes. And those electrodes will pick up the electricity being generated by the neurons which are near the eyes. So if we place some electrodes on the sides of a person's eyes, below his eyes, above his eyes, then we can make out Supposing the sideway neurons are active, the eyes must be moving sideways. If the up and down neurons are active, the eyes must be moving up and down. So we can come to know what is the direction of eye movement, also the speed of movement of the eyes. How fast the neurons are coming into activity, that rapidly his eyes must be moving. Now EOG requires, in the same way that EEG requires that scalp electrodes be attached to the person's scalp, EOG requires that electrodes be placed near his eyes, and in the same mechanism there will be metal disc picking up electric information of the neurons near the eyes, and they will send it by means of wire to the machine, the EOG machine. And so we come to know the direction and speed of movement of eyes. This completes the psychology being investigated. Okay, if you have found it a little difficult, which I don't think it is, but if you have, don't be discouraged. Firstly, all the studies are not so technical. I think Dement and Kleitman is the only one that is. And there's no harm in spending a little extra time and understanding well what is being explained here. As I told you earlier, it will help you generate interest, and it is meaningful. It is very useful in the subject of psychology to investigate things like dreaming and sleeping. As we move forward with this study and we come towards the completion, we'll understand the significance of this study. Okay, so to summarize what we've seen in the psychology investigated, we have seen that the study is about finding out in which stage of sleep dreaming occurs with the help of machinery or sophisticated brain study techniques which are called EEG and EOG respectively. All these concepts we have to explain if they ask us in the paper, as I will show you ahead. Very shortly I'll be discussing what type of questions come in the paper. Okay, let's come to the background of the study. Okay, in the background of any study, what we see is why the study was conducted. Whatever behaviors are there, that psychology is interested. Psychology is interested in all of human behavior. So whatever behaviors are there, lot of studies have been done on each of them. So whenever you come across any study, be assured that that is not the first study on that behavior, nor is it the last. So if Dement and Kleitman were looking at sleeping and dreaming, lot of researchers had already looked into it. Now research is an expensive enterprise. It's very time and money consuming, effort consuming. So there always has to be a justification for why a study is being done. Any researcher cannot get up and say he's curious about something and start studying that aspect. He has to justify what is missing in what has already been found out about that behavior in past studies, which warrants that he should consume so many resources and conduct his study. So in the background, we see what is the justification for conducting a study. In terms of paper point of view, exam point of view, for every study, the background is not directly asked about. In Dement and Kleitman, it's not expected to be asked about. So far, it hasn't been asked about any time. But in some of the studies, background is very important, such as the Baron-Cohen study, which talks about the original eyes test. The Pilyavin study, which talks about the Kitty Genovese case in the background. Those backgrounds are directly asked about in the paper. Dement and Kleitman not expected. But from an understanding point of view, from a conceptual point of view, your understanding of a study remains incomplete till you understand why the study was conducted. So for your own interest, definitely you should know what was there in the background, even if it is not going to be asked in the paper. And it's a very brief discussion. In past researches of dreaming behavior in humans, lot of subjective measures were used. What is there? Dreaming is one activity that you cannot see directly. So you cannot, I want to understand what another person is dreaming, I cannot go into his mind and start seeing what he is seeing in his dreams. I have to ask him about it. So if I want to know when the person is dreaming, I have to wake him up and ask him, were you dreaming just now? If I want to know what he's dreaming about, I need to ask him, what is it that you dreamt about? So he has to tell me what he has been dreaming about, and that is very problematic. I hope you have done your research methods already, so you would know the problems of self-report. If you haven't, you will come to know as you study. When we ask people for information directly, that is, they have to report their own information to us, there can be a lot of distortions. They can deliberately hide things. So if I'm asking somebody about his dreams and he's embarrassed to admit something that he saw, he just won't tell me about it. They are also prone to distortions in the sense of memory of people can be weak. So I'm asking somebody, have you been dreaming? He does not remember he's been dreaming or not. So subjective measures have a lot of inherent problems with them. So they are never good in studying any behavior. But dreaming is such a personal experience of a person that we don't have much of an option but to ask that person what he has been dreaming about. But psychologists, because they are good scientists, they try to overcome these problems. So they know some things are very subjective, but on their part, they are trying to make objective measures to study the same. So Dement and Kleitman wanted to make an objective measure of dreaming. Simply saying, without asking the person, they wanted to get as much details about his dreaming behavior as they could, because they felt then the information will be more accurate as compared to if they ask him directly for it. Now, the researchers were not the first to study dreaming. For sure, a lot of people had studied dreaming from the beginning of psychology, even before that. They were also not the first ones to use EEG technology to study dreaming. One researcher of the study, Dement himself, with another researcher, had done one study previously using EEG technology to study in which stage of sleep dreaming is occurring. So, to meet a similar objective as is the one for this study. Unfortunately, in that study, he was not able to maintain very good rigor. Rigor means good study standards or accuracy in what he was studying. So what Dement decided this time, and his colleague Kleitman joined him in this, that they are going to use a more rigorous or a more accurate way of studying dreaming with the help of EEG. Means they are going to provide such evidence, or they are going to collect such evidence from their study that cannot be debated. So they were going to make the study as valid as possible. What did they do for this? Firstly, they made sure that whenever they were going to ask participants about dreaming, there would be no contact between them and the participant. See, it is their objective, or it's their long-term goal to have an objective measure of dreaming. As of now, they don't have it. When they are conducting the study, they are still establishing it. So what they had to do, as we'll see ahead in the procedure, whenever they were seeing in the EEG machine, supposing that a person is in REM stage of sleep. Now they're expecting he's going to be dreaming that time, as we've seen in the psychology. But they needed to confirm that with him, that are you dreaming at this time? Because otherwise, how will they show that yes, when the machine shows the person is dreaming, the person is actually dreaming. So that means in the course of their study, they had to wake up participants many times and ask them whether they had been dreaming or not. Now, when they had to do this, if they would come in contact with the person, means if they would ask the participant, going physically close to him, waking him up and ask him, have you been sleeping? We can imagine, have you been dreaming? We can imagine what effect that would have on the participant. Imagine a researcher comes to you, wakes you up and asks you, have you been dreaming? Firstly, because of the human contact, you might get a little startled because you've just got up from your sleep and you might just forget whether you had been dreaming or not. Secondly, you might be hesitant. As we saw earlier, we can be embarrassed to admit some things to a researcher, or his presence, his expressions, the way he's responding to our dream content could cause us to forget some things, hesitate about some things. So whenever there's human contact, when questions are asked, the presence of the person who's asking the questions can have an adverse impact on what the other person is reporting. So that reduces the rigor or the accuracy of what's found, because the person is missing out on some details or he's not able to talk freely. So researchers decided that in their new study with EEG on dreaming, they will make sure there is no contact between the experiment and participant to avoid all these troubles. Secondly, they wanted to know as much about dreaming as possible with the EEG machine. They wanted to completely omit the need for subjective reports of dream from psychology. So for that, they not only wanted to use the EEG machine to find out when a person is dreaming. Okay, the EEG machine showing he's in REM stage of sleep, so he must be dreaming. That's not all that they wanted. They also wanted to know if for how long the person is in REM stage of sleep. For that much time only he's dreaming, because then in future what they would be able to do is just study the EEG activity of the person and say, okay, he's been dreaming for 5 minutes or 10 minutes or whatever duration. Means they would not even have to ask him how long you've been dreaming. Even that they would come to know just by looking at the machine. So even that they would come to know objectively. So here they wanted to establish whether there is a correlation between duration of eye movements and reported length of dreaming. How long the eyes are moving, for that much time only the person is dreaming or not. Again, I hope you've done your lesson on correlations. You would know what a positive correlation is. One thing increases, the other thing also increases. That means as the person is showing more and more rapid eye movement, the more and more time for which he is dreaming. That is what they wanted to establish. And to know even more about dreaming just by the help of the machine without asking the person, the researchers also wanted to see whether they can make out what activity a person is seeing in his dreams, which is amazing. So they wanted to find out what the content of a person's dream is. Of course, they could not know it fully. Technology is not yet so advanced, but how much they could, they wanted to know what a person is seeing in the content. What they believed was, if our eyes, when we're in the REM stage of sleep, are moving left and right horizontally, then what we are seeing in our dream, that must also be having a horizontal movement. So for example, if I'm sleeping in REM, eyes are moving horizontally. In my dream, I must be seeing a car moving horizontally on the road or someone running from left to right. So there must be some horizontal movement in my dream activity, dream content. In the same way, if I'm sleeping in REM stage and my eyes are moving up and down, so in my dream content also someone must be jumping or something must be moving up and down, like say there's an elevator going up and down. So they felt that by looking at the EEG recording, the EOG recording, the electrooculography, and seeing what is the direction of eye movements, they can say what direction of activity is taking place in a person's dream content. So that also they were going to find out in this study. So what we are seeing in the background is, firstly, they wanted to make their study more valid by reducing that contact, in fact eliminating that contact between the experiment and participant, which they felt tends to distort subjective reports of dreaming. Secondly, they wanted to establish some aims that they had not previously. These last 2 points that we have seen were not established in the previous study. So they wanted to establish that as well. And so they wanted to be able to establish an objective measure of dreaming to a great extent as possible. Not only to find out when a person is dreaming, but for how long he is dreaming and what he is seeing in the dream content as well. So this was an ambitious study that they had come up with. Based on what we see in the psychology of any study and the background that we note, aims follow accordingly. Aims of a study are the objectives of the research. What is the purpose of conducting a study, or what they are seeking to establish at the end of the study? Actually, that's more of hypothesis, but in our syllabus we don't see hypothesis, so we take that from the aim of the study itself. For now, you can understand aims are the goals or the objectives of a study. So very logically, following what we have just seen, the researchers wanted to firstly investigate which stage of sleep dreaming occurs in, REM or NREM stage. They wanted definitive evidence that it occurs during REM stage of sleep. The next thing they wanted to know was, what is the relationship between sleeping and duration of dreaming? That is it that for how long REM stage of sleep occurs, for that long only a person is dreaming or not? And lastly, they wanted to know whether there is a relationship between the direction in which eyes are moving when a person is in REM stage of sleep and the direction of activity that is taking place in his dream content. So these were the 3 things they wanted to establish with their study. This completes the introduction of the Dement and Kleitman study. Now that we have done the introduction, we should look at what type of questions come in the paper from the introduction. In my classes, that is what I do. When we do any significant part of a study, then we look at what is coming from past papers, because my ideology is we should not keep the past papers waiting till the end. I see a lot of students doing that, and that's bad strategy. First, they just complete all the syllabus, that is, they keep on understanding the syllabus, and then just before the exam, 1 month before, 2 weeks before, they look at the past papers. Now, what happens when you do that is, all along you've been understanding the syllabus under the assumption that you'll be able to answer the past papers very easily. And when you actually see the past papers 1 month or 2 weeks before, you realize that you did not prepare the syllabus in a way that was required for the past papers. And now you have lost the time. You have lost a lot of precious time, because at that time you have to learn other subjects as well, because exams for those are also coming up. So you don't have time to go back to the whole syllabus again in terms of the syllabus guidelines. So why not right from the beginning know what type of questions are asked in the paper and keep preparing, keeping those in mind, right? And one more thing is that when you do so much at the end, it's so burdensome to do all kind of past papers, become monotonous also. First you're just doing studies, then you're just doing past papers. This gives you a little break also, understanding, preparing for the past papers. You understand something, you write something. It's a good alternating between, which keeps your interest alive. And also, as I told you earlier, it will help you to prepare well. You won't have a lot of burden at the end that so many studies you have to answer the past papers for. You'll also feel more confident in this way right from the beginning. You'll know that you'll be able to answer questions from past papers. Okay. From the introduction, we have to know that questions can come from any of the psychological concepts that we've seen under psychology being investigated. So they can ask the entire psychology being investigated, as we'll see ahead, for 4 marks or 5 marks. Every year there is one question on psychology being investigated in one of the studies. So there are 12 core studies. One of those studies will be asked for psychology being investigated. So make sure you know the psychology investigated in all the 12 studies, because then you are sure you'll be able to answer one question. Sometimes they don't ask the entire psychology being investigated, rather for 1 mark or 2 marks they can ask some particular concept that was there in the entire psychology. Okay, for example, they can ask what the EEG measures. So that is what we saw in the psychology being investigated. Now when I'm showing you these past papers, firstly, what are these past papers? These are the papers that I worked out with my students in class. So what we do is, we do any section and then we bring up the past papers. I show them on the screen like I'm showing you right now. I ask the students from their understanding to give me an answer of the question. Whatever they give, if I feel it's correct, we write it together. So I've written on the screen. Or if I need to make some changes in what they are saying, then we make some modifications and then we write the answer. So these are those papers which you're seeing on the screen. And the answers that are there, I won't show you repeated answers, which I've done with too many students, so I don't want to keep on showing the same things again, but I'll just show you 2 or 3 different answers to the same question, just to show you that there's no hard and fast rule of how you should be answering a question in the paper. There's no fixed wording. You don't have to rote learn or memorize something and answer. You can write in your own words. So for example, one student, when I asked her what does EEG measure, she said it measures the activity of neurons in the brain, which is correct. Okay, and this question you can see it comes for 1 mark from the psychology being investigated, because it's a very direct, simple question. In the same way, they can also ask us about the aim. In the introduction, we saw about the aims. Okay, so in 1 year, they asked about one aim of the study. Okay, now some studies have multiple aims like we just saw. Then the question arises, do we need to prepare just one aim because they ask for one? No. Sometimes they ask for 2 or more aims also. Mostly they ask for 1 or 2 aims. If a study has only 1 aim, they won't ask for multiple. So then they won't ask for 2 or 3 aims. But if a study has 2, 3 aims, they can ask 1. At most I found they ask 2, but you never know. They could ask for 3 aims also. So they could ask for all of them as well. Okay, so if they've asked for 1 aim, you have an option. There were 3 aims. You can outline any one. That is up to you. So here, like you can see, one of the students in the class, when I asked her for 1 aim, she said that it was to investigate about the direction of content in the dream, whether it matches with the direction of eye movements during sleep. She chose to write about the 3rd aim. She found it easy to explain. So that's up to you. Okay, again coming back to the previous question, I'm sorry the order has been mixed up, but please bear with me. We saw one question earlier, just before this one. What does an EEG measure? Okay, now what an EEG measures, I told you one of the students I just showed you, she said that it measures activity of neurons in the brain. Another student was a little more detailed about it, her understanding was a little deeper. So she said it measures the amplitude and frequency of activity of neurons in the brain. This is also correct. So you can see everyone can have their own way of answering. The point is that both these students, even their wording being a little different, both of them have correctly pointed out what the EEG measures. One is pointed out in more details, one little less. It's basically talking about, we have to talk about brain activity or activity of neurons. So we have multiple ways of answering the same question. The only restriction is that when it's for 1 mark, we should give the answer in one sentence. This one answer is a little detailed, but it's acceptable. It shouldn't go into more details. Like if here the student was to explain what is meant by amplitude and what is meant by frequency, that would not be appropriate. So we don't need to elaborate any further. That would be warranted for 2 or 3 marks, not for 1 mark. So we just have to restrict ourselves to naming what it is that is measured. We shouldn't go into an explanation of it. So you can see in both the answers that is common. Okay, also I forgot about this, like these are actual past paper questions. You can see always on the bottom of any past paper, you will get to see the variant, the year. So this is October, November 2018, paper 3rd variant, paper 1. Okay, so from here you can make out these are actual questions of the past papers. Okay, then you can see again, like I told you, the order has got mixed up, so I apologize for that. But again, the aim has been asked for. Now previously we saw one student chose to discuss the second aim, to name the second aim of this, the third aim of the study. She spoke about the direction of activity in dream content and direction of eye movements. This student chose to write about the second aim of the study. So she told me one aim was to see the duration of sleeping, whether it matches with the total duration of REM sleep. That is also perfectly correct. You can write about any of the aims when there is multiple aim, as long as you write it correctly. Also, one more thing is, whenever we are writing about an aim, do make sure you start with the wording to investigate. That is the problem. Some students have strange ways of writing the aims of a study. Like they'll say, they write it in a question format. Does the duration of dreaming match the total duration of sleep? It will be marked as correct, but that's not a good way of writing. Think about the aims correctly, in the correct format. If you pursue psychology further, or if you pursue any science further, which you are most likely to do, it will help you to write your papers in future correctly when you go to higher levels. So if you develop the wrong formats right now for small things like writing aims in question format and all, you will have difficulty ahead when you have to write more serious reports. Okay, one of the students, when I asked her the question about what does EEG measure, she said it measures brain activity. And this is correct. Whether we say activity of neurons, amplitude and frequency of neurons, brain activity, all of these are correct. The question that can come from the type psychology being investigated is, name the technique used to measure brain activity. Now, name type of question, when the command term is name, there are some technicalities in answering questions like the marks allotted, command terms. I do discuss them on my website from time to time, so you can visit that, as I pointed out earlier. I'll try to make some videos about command terms and marks allotted, how to write answers according to that. Anyways, for now I can tell you, when the command term is name, we have to be to the point, just name something, not elaborate on it at all. And anyways, it's allotted only 1 mark. So that also indicates we just name or identify something. So the technique used here was EEG, electroencephalography. We should write the full form, not just EEG, it has a proper name, so we should be giving that name. So this type of a question can also come from psychology being investigated, and we have to answer it very simply. Okay, another student, when I asked her about the aim of the study, she also chose to write about the third aim. So she said direction of eye movements and direction of activity in dream content. You can see it's very similar to what the student had earlier answered when she also wrote about the third aim. Wording can be slightly different. That is what I wanted you to see. Wording of students can be little different. Okay, this one I think we've gone through earlier. Okay, now coming to the more lengthy questions which students find a little more difficult. Psychology being investigated in a study. So like I told you, it can come for full 5 or 4 marks. Generally it comes for 5 marks. And like I told you, for any one of the course studies it can come. When they ask us for psychology being investigated, we might feel there are too many details, because while understanding, while explaining to you, I go into a lot of details. So exactly how are we to put it in a 5 marker, that becomes a challenge. First thing I want to tell you is, for explanation's sake, I elaborate on many concepts, like I pointed out there also. Everything does not have to be written in the paper. Second thing is, many students come to believe, if this is only what I have to write for 5 marks, why should I learn so much? And let me just learn 5 sentences. So they make some kind of target of calculating words and sentences and preparing. That is dangerous, let me tell you. If you prepare just 5 sentences because you assume, okay, maximum 5 marks question can come, let me answer. There have been a lot of problems with this, we have seen in the past, because sometimes what happens is, you'll see in other studies, it's not been there for Dement and Kleitman so far, but they can just pick up one of the concepts and ask you for 3 or 4 marks. So supposing they are to give you a 3 or 4 marker on what is NREM stage of sleep, and you have prepared just one sentence from NREM stage because you believe it will come just for 5 marks, so you don't need to learn more than one sentence. Then if it comes for 3 or 4 marks, how will you answer the question? So don't be overconfident about things, or don't make decisions just by looking at 1 or 2 questions and making assumptions of your own that, okay, if I prepare this way, it's okay. Know your papers fully, go through your past papers fully, and then make these type of decisions. Okay, so it is good to learn about all concepts in sufficient detail that even if they are independently asked about, you can answer. There have been such bad experiences that school teachers have told students that if these type of questions come, like if they ask you about NREM or REM stage in details, you can't do anything about it. It's unfortunate, you cannot even attempt those questions, you have to only lose marks. Let me tell you, there's nothing of that sort. You don't have to lose marks. If you prepare well, you can definitely score on those questions. Okay, now for the Dement and Kleitman study, let us just understand how we put down what we have learned into 5 marks. When they ask us for psychology being investigated and there's so much that we've understood that we're ready to write about, we need to pick up roughly, as a rule of thumb, it's 5 marks. Let's pick up 5 to 6 sentences. It's not compulsory, I'm just giving you a rough guideline. So we pick up 5 to 6 sentences with those 4 or 5 concepts which we feel are critical to explain, and we give 1 line on each. 1 line sufficiently explaining each. So that is how we can prepare the answer. In the first sentence, we should explain in gist, or in 1 line, the totality, the overview of what they were investigated, because then the concepts will follow. Otherwise, if I just start, this is dreaming, this is sleeping, it just looks like I'm listing out everything. So first let me give 1 line, okay, this is what they were investigated, to make it clear why I'm explaining the remaining concepts. So first I say overall they were investigating stages of sleep and dreaming. Then because it's required, I follow with the definition of dreaming, which we just saw in the notes. I'm not explaining it again, but I've given a 1 line definition on dreaming. Then we give the 2 stages of sleep, because we just mentioned in the first line 2 stages of sleep, so we need to explain which are those 1 line on each, because the answer is for 5 marks. So I cannot go into too many details of each. I won't be able to complete the answer. I'll miss out on the rest of the concepts. So in 1 line I've explained what is REM, 1 line NREM. For REM we have mentioned that the brain activity is high. For NREM we have mentioned that brain activity is low. Instead, like I told you, wording can be your own. So for REM you could say it's low amplitude, high frequency sleep. For NREM you could say high amplitude, low frequency sleep. When I was discussing this with the student with whom I have written this answer, she tends to remember things in simple language. So she's put it simply. If you're someone who can remember terminology better, you can explain it in terms of terminology also. That's good. As long as you're making a correct point, wording does not matter. Okay, then we also of course have to talk about EEG and EOG. So we have given 1 line on each. Very important sentence is, I forgot. Dreaming is believed to occur in REM stage. See, when we are saying in the first sentence that they were studying the relation between sleep and dreaming, you cannot miss on this key point, that dreaming occurs during REM stage. That is the connection they were trying to draw. So that sentence is very important. And then we are explaining in 1 line what is EEG, what is EOG, to measure brain activity and eye movements. Again, very briefly. We don't go into the details. Electrodes are there. They are connected to a machine, because they have not asked us about EEG or EOG independently. If they were to ask me one question, 3 or 4 marks, what is EEG or what is EOG, then I would go into those details. Not for a 5 marker which is covering all of this psychology. So what has been the strategy here is to first outline overall what is the psychology, and then in that overall outlining, which are the concepts you've mentioned, explained each of them in one sentence, to clarify all the concepts that were vital or that were central to this study. Okay, so for the psychology being investigated, I have picked up one answer only, because the rest of them were very similar to this. In all the answers that I wrote with my students, we discussed this only: REM, NREM, EEG, EOG, dreaming. These were the concepts that we defined in the same way. Okay, so this is my lesson for the introduction of the Dement and Kleitman study. As such, on my website long ago I have posted the entire notes that are required to prepare for this study, and from time to time I keep on publishing tips on my website, on my video lessons also, how to write in the paper, so you can find something that's useful for your paper 1 and paper 2 also, if you look at the website and videos carefully. That will help you prepare for Dement and Kleitman as well. I'll try to come up soon with the next section, which is on the method, which I'll be beginning with the sample. So what we do is we go through the introduction, then we come to the method, go to the sample procedure. That is how we progress. So I'll try to come back soon with that lesson. Until then, I hope this lesson is useful to you. Study sincerely, seriously for your paper. Your grades really matter for your admissions ahead. So take your studies seriously right from the beginning, and both AS and A levels both count towards that dream admission which you want in whichever university you're aiming for. Okay, so with that, thank you for watching my video, and I'll try to be back soon. Goodbye.